Hello, 30-1 friends. A short lesson on inverses and the horizontal line test. The reason why we want to focus in on this lesson is because this has become a standard question on almost every single diploma. In fact, what we're going to do is we're going to look at a diploma question right now, looking at number 6 here. So number 6 is asking us to restrict the domain of a function so that the inverse will also be a function. Okay, well, before we can answer that question, we better know what the heck does this even mean? So draw my Cartesian, and in this case, this question is a parabola. So it's looking, I don't know, something like that. Let's go back to grade 10 for a second. Back in grade 10, you performed a test known as the vertical line test. So what the vertical line test said was if we draw a vertical line like that, and it intersects our graph in only one spot, we have a function. So the vertical line test, I'm just going to write VLT. The VLT tells us this. If we draw a vertical line and it intersects our graph only once, we have a function. If it intersects our graph more than once, we do not have a function, we have a relation. And for us in 30-1, we almost exclusively want to work with functions. Okay, so that's good news. So I'm sure a lot of you remember that from grade 10. But that's not what this question is asking. This question is talking about making the inverse of function. Okay, well, remember inverses are undoing something, or the other way to think of an inverse is to say, I'm going to switch the x and the y's. Well, think of that for a second. If we have the vertical line test, which is an x value, and we switch it to a y instead of the vertical line test, you're going to end up with the horizontal line test. So I'm going to draw a horizontal line. So what I say to myself is this. The horizontal line test, the HLT, again, don't use abbreviations on your diploma. The horizontal line test tells me this. If a horizontal line intersects my graph only once, and here's the most important part, because so far it sounds the same, the inverse is a function. If a horizontal line intersects my graph only once, the inverse is a function. Okay, so I look at this graph. How many times does my horizontal line cross my graph? It crosses it twice. It intersects it twice. Okay, so what that tells me then is that my inverse is not a function. Now that I understand that, now we can actually answer the question. The question says, what are we going to do to the original domain so that our inverse is a function? So here's how I want you to think of this. We're essentially going to say to ourselves, okay, I want this horizontal line to only intersect my graph in one spot. Well, I'm going to say I'm going to cut off parts of my graph then. I'm going to restrict my domain. Well, what I'm going to do is I'm going to cut my graph in half. I'm going to look at my vertex. Picture this. What would happen if we cut off that half of the graph? How many times would the horizontal line cross our graph? Once. Since the horizontal line only crosses it once, the inverse will be a function. Okay, so I could cut off that half of the graph. Or, similarly, draw that back in. Instead of cutting off that half of the graph, we could have cut off this half of the graph. Again, if I cut that off, my horizontal line is only going to cross the graph one time. Okay, so I see two kind of standard answers here. So what I need to know is where that vertex is. Well, that vertex, looking up here in vertex form, my vertex is at C, comma, D. So my two restricted domains, if I cut off the left side, like I have shown right there, my new domain would be this. And if I cut off the right side, my new domain would be that. And now I just need to look at my multiple choice question and say, okay, there's only going to be one answer. So the answer is C. In fact, there's an infinite amount of answers for this question, but in a multiple choice, you're just looking for one. Okay, let's try one more. So this graph here, again, has two important things in it. So this question here is asking us about finding the number of invariant points. We'll do that in a moment. I want to do the horizontal line test on this. So if I draw a horizontal line, it intersects my graph way more than once. So the inverse is not a function. So if I wanted to restrict my domain so the inverse is a function, look at, there's again an infinite number of answers, but what I would try is I would cross off all of this. What if none of that was there? How many times does my horizontal line cross the graph? Once. So one potential restricted domain would be this, the set of numbers x such that x is less than or equal to -3. X is an element of the reals. There's one possible answer. Another possible answer would be this. What if I crossed off, I don't know, all of that? And I just looked at that x-intercept. My horizontal line only crosses it once, so now I could say this. There you go. Okay, so the horizontal line test is helping us find if the inverse is a function. So that's what we want to do when we see that question. Okay, very important. Now, while we're here, my friends, let's answer this question anyway. So the actual diploma question they asked us was, how many invariant points would occur if the graph is reflected in the line y equals x? Okay, that's an inverse. That's an inverse. Okay, all you need to do for figuring out when invariant points are is draw the line that you're stretching or reflecting about. So all I'm going to do is draw in the line y equals x. 0, 0, 1, 1, 2, 2, 3, 3, -1, -1, -2, -3, keep going. Now, on a test, I'm going to pull out a straight edge, do the best I can here. Looks like that. Okay, there's the line y equals x. So now all I need to ask myself is how many times will my graph intersect this line? Well, clearly right there and right there. Will it ever cross it again? Nope. So how many invariant points? The answer is B, 2. So not a bad question. But look at, this was a diploma from 2019, I believe. We just answered 2 questions with a nice small 10-minute video. So when you're looking at inverses, the big questions are restricting the domain and figuring out how many invariant points. The other big questions are about finding the equation of the inverse and maybe something to do with domain and range. But those are a little more simple compared to what we just did. Okay, my friends, I hope that helped. Good luck. Have a great day.